This is the Earth Science Classroom. Welcome back. This video is in the rocks playlist. It covers both geomorphology and obviously different types of rocks and how we form rocks. And it's all about the difference between weathering and erosion, how they connect. So this video is going to look at, in more detail, both definitions, obviously, then explore the connections, the relationship, and how it overlaps in nature from both these processes, and then the combination of these processes over time and in different locations will create these beautiful landscapes and help to constantly work and sculpt our planet's surface. So it acts as a destruction kind of thing or notion or process, and also can be a construction and can construct the landscape as well in terms of depositional environments. And then you got the combination of tectonics and how the crustal movement as a large scale system can affect the rate and the location of weathering and erosion. So, definition of weathering is the physical or mechanical, or, big slash there, or chemical breakdown of rock into smaller pieces, and these are called fragments, or they're called, in more general terms, sediments. So the chemical is where you'd probably change the composition, but compo, right? You'd change it due to the rearrangement or addition or subtraction of atoms, elements within the rocks as you're breaking it down. And the physical, or another term is mechanical weathering, is just the brute force. The brute force action of breaking down rock, usually with other rocks. So it's rock on rock. So erosion is the removal of such sediments through various what's called agents, or different ways or methods or varieties of transporting different size sediments from one location to a new location. Once that new location has been established, we call this the drop-in of the sediment through gravitational forces, and the energy within that agent, whether it's continued or just diminished energy, would deposit, or we call deposition as the process of dropping that new location, that sediment again. So different environments are created. So really, weathering kind of comes first, with a close second, erosion, and these guys work in tandem to create the sculpting of the landscapes. So connections. So as I've said before, weathering comes first, followed by erosion as a second. Then we get, obviously, a third would be deposition. And then you'd start the sediments going through the process of what's called diagenesis, which is the stages of forming a sedimentary rock. Now, how it gets tricky? Well, these can work concurrently together, both the same time and same location, and using the same types of weathering techniques, and also the same type of erosional agent. So again, there is that step-by-step process, but they also work together in tandem. Okay, so let's take a fluvial system. Let's take a river or stream. And obviously, looking at water, okay, looking at overland flow, looking at gravity and its effect on the water to go down to sea level eventually, either through the ground, in this case on the surface. Looking at different types of water erosion, so with rill, gully, stream, different sediment loads, bed load, suspended load, but you're looking at the different types of erosion, the transportation, and at the same time, that sediment that is being transported at different sizes, from pebbles to sand to clay to boulders, whatever you want the size you're looking at, depends on the river energy. You're looking at abrasion, okay? Looking at the movement along the riverbed. So these two combined, obviously the river's going to not only break down the rock, river bed, the river banks and sides, but also at the same time that water is going to transport the sediments downstream based on the gradient, based on the stage of the river, and obviously based on the amount of energy the river has inside of it. Okay, so that's a good example of how they combine. All right, so we had the frozen water now, ice. We have the ice caps. We have the continental and regional. We have the glaciers or glaciers. So again, glacier is a frozen river moving downhill through gravity and mass movement. We have the obviously the transportation, the erosion component of moving material kind of downstream basically, or down glacier to the terminus, okay, from the origin where the glacier is added to, okay, to the terminus where it ends. Based on the climate, okay, and the gradients, you can see what's going to happen with the energy and the size of the glacier. And then obviously the deposition, different environments that can be created by the depositing of the glacial material, erratics from the terminal, medial, and moraines, to the alluvial stuff when it starts to melt, the basal flow, and so the erosion, obviously the plucking as well, so not erosion, weathering, the plucking, and obviously abrasion aspect. Plucking is how the freeze, thaw, and the glacier work together, plus the mass of the glacier to basically weather down and pick up any kind of loose material from the actual bedrock that the glacier has fallen over. So again, a great example of how they connect. All right, so next one's oceans and coastlines. This one's awesome because this is obviously, 2/3 or maybe 3/4 of the earth is covered in ocean. Salt water with the freshwater combination, groundwater, and the parts of the water trapped in ice and ice caps. But the oceans are a huge driving force of energy from the sun, so thermal. You've got wind creating currents. We have deep water circulation based on temperature and salinity. And you've got upwelling and sinking of millions of tons of water every second around the world. You also have currents and tides, which add into the winds and stuff. You also have storms, tropical cyclones, mid-latitude cyclones off the coast. So all these things can run up the oceans, and when it meets the coastlines, it can cause huge amounts of weathering based on hydraulic action, based on waves, based on the swell, which is again based on distance and consistency of wind. So, and also you got the topography of the coastline, which can dictate the wave. Is it plunging? Is it spilling? You also have the cliffs. Is it going to be a flat kind of beach coastline? So all these things can change and affect the amount of weathering that can occur along the coastline. Also, the rock geology have an impact. Now, obviously the way water can transport not only heat and energy, but also can transport loads amount of sediment. Close to the beach with longshore drift and longshore current, different sandbanks and barrier islands and different areas of deposited sand with tidal flats and marshes. But sediment is a huge amount of movement along the beach, along the with cliffs, with the gravel, and kind of like fallen rock, which again is gravity and mass movement. So all these things play a part in how both the combination of erosion, the movement of that material, and then obviously the collision impact and sheer force of the water taking not only the water itself and hitting it, so it's hydraulic action, but also the carried material, the rocks, the sediment, and hitting the coastlines and the beach and transporting and weathering that material all across the world. Last one's wind. So I've mentioned wind in other areas, with the oceans in particular, but wind across the Earth's surface can pick up, usually in arid or drier climates or environments where maybe the soil erosion and degradation is optimal, the parts of the upper layer of the soil and the crust is going to be easily transported, plus weathered through thermal expansion, maybe even freeze thaw in certain areas where at nighttime it drops down below zero. So you might have, and obviously flash flooding, but in terms of wind, the picking up and transporting of material is huge in terms of just the suspended load based on the density and the size, and also the material that's pushed along the surface will cause large amounts of weathering and create specific landscapes and patterns on the surface based on that wind pattern, how the material and wind is shaping the surface as it flows over. And again, the wind is originates from the difference in temperature on the Earth's surface, which creates difference in pressure, and to equalize and move between the pressures, the air is going to move from a high to a low pressure, therefore creating wind. And the wind direction, the wind moisture, wind strength, based on cyclones and low pressure, high pressure systems, cyclones and anticyclones will dictate what happens to the surface. So it's all interconnected. Again, huge earth science system kind of topic. And wind is the last example. I hope you guys enjoyed the video. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel. And don't forget to subscribe. Thank you again.